Let's move on to the next one. Give me a sec. I would like to switch from this. Give me a sec. Now, let me first walk you through the Hadoop diagram, and this condition does not have that. Cool. I think I will go ahead with this. So I hope you're able to see the geeks for geeks link, right? And this architecture diagram.
Yes.
Perfect. Perfect. I will paste it in the chat also. Just on this page. Now, where is my list here? I will take Sayali. Sayali, are you there?
Yes.
Awesome. Would you like to volunteer for this exercise?
Yeah, sure. I'll try.
No worries, no one. I mean, so just answer to the best of your knowledge. Okay,
Yeah.
that should be fine. Now, Sayali, but what you are able to see on this thing is what we call a typical Hadoop architecture diagram. Okay, what are the different components that you are able to see?
Master is there. It's node resource manager, and it's 3 slaves. It's
Okay.
data nodes, node managers, and mapping.
Perfect, perfect. Thank you. So, what Sayali said, according to that, we have a master. Another name for master is what we call this master as a name node.
Yes.
Okay. Then, but Sayali told us that, okay, master has resource manager also. What Sayali is able to see, that this guy master is what we call as name node, and he has a resource manager. And what master is connected to is 3 slaves. And what these 3 slaves are further called data nodes.
Data nodes.
Correct. And all of these 3 data nodes have further node managers. Okay. Now,
Yes.
but what you are not able to see here, just remember 2 more things that these data nodes will have. One, this data node will have something called task tracker, TT. Okay.
Okay.
So
Okay.
just remember that these slaves have task tracker also, and this master has job tracker.
Okay.
Okay. And what else? I think that's it. So now we know all the different components.
Yes.
Name node, data node, resource manager, node manager, task tracker, job tracker, and assume there is another friend of this guy, master, what we call as a backup node or a secondary name node.
Okay.
So now everyone is with me. We have around some components which are not visible here, but they are there. Like a friend of master, a backup, which we call as secondary name node. And then there are something called as in data node, which is called as task tracker. Actually, I'll write that, and it might be easier for you to remember. So here we will have oh, this is not right.
Shubham, you can write using Zoom pencil.
I was trying to do that, and somehow this is now not getting deleted. This got stuck. Yes, we are all right. Yes. Now, where is it? I'm trying to write using mouse. Somehow over this image, it's not working. Why? This somehow that was working. Give me a sec. Give me a sec. This is the correct one. Why it is not working? Okay. Now this is working somehow. Okay. Here we are. Sally is there with us. Now we have a pencil and we're gonna write it here. It has something not vanishing one. So this one is spotlight. Somehow I'm not getting that one, which is not getting erased. But okay, anyways. So just to be on the same page, Sally, this one has TT as tracker. This one has JT
Yes.
tracker. And there is a friend of this guy, master. The secondary, you can say name node, correct?
Yes.
Okay, now J Surya is able to write. Which one is it, J Surya? J Surya, you are on mute if you're saying something. Can you tell me which pencil have you chosen from this annotate? You are still on mute, J Surya.
Yeah, yes. Just there is an option when you're clicking on that, right?
Which option? The format one? Oh, okay.
Not this one, not this one.
No, again, this is going away. Then which option is it?
Yes, then like draw.
Okay, draw one.
Yes.
Oh, okay, okay. That's what I got confused with. Perfect. I think this would do. Now let me select a color. Red would do. So yes, this is TT. JT. Then there is
secondary.
name node. And what else? Everything else is there, right? Are we forgetting anything, Sally?
No, two slave also have TT, right?
All the slaves have TT. All
Yeah.
the slaves have TT. So
Okay.
all the slaves have TT. Now let's start. So what this architecture, I mean, how does the Hadoop system work? So Hadoop has this master node, but we also call as name node, which will be nothing but managing all the other slaves on the system available. Now all these systems or these slaves will be available on a network using which this master can talk to these slaves.
Yes.
Okay. Now, don't you think so? These slaves should tell something to this master so that this master know that this slave is available.
Yes.
What we call that thing
Heartbeat.
is heartbeat signal. Yes, that thing is what we call as heartbeat signal. So this
Okay.
slave keep sending this master a heartbeat signal that hey, I'm alive.
Okay.
As soon as that heartbeat signal is stopped by the slaves towards the master will assume that this slave is not available anymore and will trigger basically you can say a restart function for this slave so that this slave can available again,
Okay.
if at all that is possible by this master. Otherwise it will just keep a record that yeah, this slave has died. Simple.
Okay.
So using heartbeat signal, this master keeps knowing the fact that hey, this slave is available to me and is available for my task to be accomplished and will give back to me the result that I want.
Okay.
So far so good. Yeah. Now this heartbeat signal is generally you don't have to configure, it's by default. It's happening as part of this architecture. Nothing we have to configure. They send heartbeat signal and talk to each other, and that's how they work. Now, another key thing that we need to know is that if you remember in the previous slide, yeah. In the previous slide, yes, here, if you remember, right, we were sending the program to the master and then master was sending the program to S1, S2, S3.
Yes.
Correct?
Yes.
Perfect. So now what's happening is we are sending that program to master and this job tracker is there,
Yes.
which is basically allocating these tasks to different slaves.
Yes.
Okay, so this job tracker is taking care of assigning the task to slaves.
Yes.
So far with me?
Yes.
Sounds fair? So once the task is assigned by job tracker to a slave, the task tracker will have a hold of that task and will try to accomplish that task using the node manager that, hey, I need these many resources, this many space, and this is what I need to do. Assign me something so that I complete my task. So task tracker will talk to node manager. Job tracker will talk to resource manager. Now, why job tracker need to talk to resource manager? Because let's say you have given a job which says that, hey, count, let's take same example of count of words. Okay.
Yes.
And now you have a file size of, let's say, 100 MB.
Okay.
So job tracker will negotiate with resource manager that, hey, I need 100 MB of space and I need resources.
Okay.
Now job tracker will say, resource manager will say to job tracker that, hey, okay, since you need only 100 MB, I will allocate you two blocks because I have one block of 64 MB. So in 128 MB or 100 MB file can be easily stored and your work will be done. So job tracker says, okay, yeah, that's fine. You can assign me two blocks. Now job tracker says that, okay, while you are assigning, do not assign me blocks on the same slave, because then I won't be able to use distributed computing. It will happen serially. Make sense?
Yes.
So what job tracker will assign to resource manager while negotiating that, hey, okay, while you are giving me two blocks of space, give me that on different slaves, and then those basically you can say that, let's say it can be slave 1, slave 2, slave 3, any of these two. It necessarily won't be like this one, or this one. It can be any two. And then this job tracker will keep a hold like to which slave I'm sending that data. Like 64 MB and the rest, how much it is? Is it 36 MB, right?
Yeah.
Yeah. At one place, it will send, so 64 MB will be there. Another place, it will send 36 MB, correct?
Yes.
Now, if you remember, right, we in the previous diagram, we were saying that data won't be transferred.
Yes. Data won't be transferred. Program is going to transfer.
Perfect. So that means data is not getting transferred. What if data is existing on a same node?
Yes.
Then what happens in that case? Then it will be a problem. So in that case, when this job tracker negotiates with this resource manager and the data is not there on any other node, all the data is there on a single node,
Yes.
then this node manager will talk to the other node manager and whomsoever this job tracker has like requested, right? Like give me slave 1 and slave 2. It will send the one block to slave 2 and it will say that, yeah, keep that block and process it for job tracker. He will send you the program and you just give him the result.
Okay.
Okay, that's how master is never sending the data. These slaves are talking to each other in terms of the data itself. I'll tell you, even that won't happen in a ideal case scenario.
Okay.
We will come to later. But let's assume right now that there is 64 MB residing on this, 36 MB residing on this. Job tracker has information that slave 1, slave 2 will do the task. Job tracker sends the program of counting words to task tracker 1, task tracker 2. They perform the task by negotiating with node manager. They perform the task, accomplish it, sends the result to job tracker. Job tracker stores the data in master, and then master returns that result to you.
Okay.
That is a basic cycle of Hadoop.
Okay.
Anyone has any question? Any questions at all? Mithilesh Patra says yes. Yes. Yes, Mithilesh. You can raise your hand instead of saying yes for question. Or you were saying yes for that you have understood the concept. I'm not sure.
Yes, Subham, I understood, but one simple question is there, while
ahead.
processing, what if the slave goes into shutdown? Like,
Good. Now we are talking about, we are gonna discuss those cases with Sally. Okay. Sally,
Yes.
help me out. Now, what Mithilesh is asking us, what if slave goes down?
Yes, that was my question too. What if it face any issues?
Okay, good. If it's your question as well. Okay, now there is a thing called replication factor, RF. Okay. What does that mean is by default that replication factor is set to 3. So if you store X data on this node, it will be replicated at least 2 more times on different nodes.
Okay. So it also like the first slave will also have replica, second slave will also have its replica, right?
Yes. So your essentially your 120, the 100 MB data, right? 2 blocks.
Yes.
Those
Yes.
2 blocks will be existing on each and every slave.
Okay.
Because RF by default is 3. If you, unless and until you have made it 1 in config file, it will be by default replicated thrice. If and also if you have 3 slaves available. If you have 2 slaves available, it will be replicated twice.
Okay.
If you have 1, then at least 1. In standalone mode, there is RF is always 1. So if you remember, right, we were talking about that there are 2 different modes: standalone mode and cluster mode. Standalone mode is a single machine there. Hadoop is using same machine as master and same machine as slave and working on that. But in cluster mode, there will be number of machines available. So if there are 3 or more machines available, then there will be at least 3 copies because by default RF will be 3.
Okay.
So your copy of data will be available on all of these 3 slaves if you haven't changed the config file. So if your slave 1 goes down, the other one is available.
Right.
Okay. Now another use of this RF is, remember I told you that data will be sent from node manager 1 to node manager 2.
Yes. Yes.
That won't be necessary, right? Because already it's there on slave 2.
Okay.
So again, data transfer is not there. But we discussed initially that data will be always there. You don't have to transfer the data anytime. Only the program will be sent, correct? So now, if you remember, now let's talk about that. Data is already available on these 2 slaves, and the master sends the data to TT. one T2, they processes it, gives back to JT. JT consolidates the result, so send it to master. It's there in the master itself. The job tracker is there in the master itself, and then master stores the data and then return to the user. That's how it's working. Okay. Any doubts so far?
What if problem occurs in master? Like,
Good.
is it also possible, right?
Yes, master can also go down. Then what happens?
And secondary, I guess, yes,
then
you're
this
right.
guy, this guy will come into.
Yes.
Now there is a cadence. You can say a backup cadence. Let's say an R. There is no by default thing for that. You need to set up in config file. What kind of backup do you want? So every R, whatsoever the metadata will be stored in master, right? In the main name node will be synced with the secondary name node.
Okay.
So let's say anytime if your master goes down and you're not able to come back, this master does not come back alive.
Okay.
You will lose only 1 hour of data that is not loaded to secondary name node, because at least 1 hour before you must have synced secondary name node with master and it has all the data before that. So your only 1 hour of data processing will be lost, not more than that. Or if you set up that time to 30 minutes, then 30 minutes, 10 minutes, then 10 minutes of data processing will be lost.
Okay.
So that's where his friend, the secondary name node, comes into the picture. As soon as this goes down, this will take back the control, and secondary name node will now control these slaves. And how he will be able to control? Because whatsoever the metadata this master has, this secondary name node has at least, let's say, an hour ago of the same thing.
Okay.
So he knows which slave has which data, where is that data residing, which program has run, what are the different tasks running on them, what they need to retrieve. What are the different results that need to be retrieved from this task, so on and so forth, everything.
Okay.
Okay. So what are the different components if someone asks? Name node, secondary name node, data node, task tracker, job tracker, node manager, resource manager. These are the components which will be talking to each other in the basic Hadoop architecture. Now, anyone has any question? It is very cleverly designed, and the way resource get negotiated is by this resource manager. And on the node, the task will be competing against each other. If multiple tasks are executing, then those will be managed by node manager. And the reason this master does not have data, because it does not have to have data. It just need to have metadata, like which data is residing where. It just need to have that information, and this master can get all of that work done by that particular information. Nothing else is required for the master in order to perform its or execute its task.
The replication of data will be also stored in the master itself, right?
I'm sorry, can you come again?
Replication of data. That replication of data will be also stored in the master itself, right?
No, so RF replication factor you will set to, let's say, 3. Now this master will only have the data about where the replication, you mean to say replicated block is stored. So let's say at the location 200, your data is stored in slave. Now the copy of this 200 location data is there at 300 location in slave 2. So this will have that data only. That at 200 the data is stored, at 300 in slave 2 the data is stored. Does that answer your question, Akshay?
Yes.
Yeah.
Shubham, I have one question.
Sure, go ahead.
So here for the replication, different tool is required, or it is inbuilt in
It is
this
inbuilt
architecture?
by default. Yeah, config file will have that.
YAML file.
Yes, YAML file will have that.
Okay.
Yeah.
And
You need to set the time for heartbeat signal. You can also change. Then time for secondary name node syncing you can change.
Okay, and for this kind of architecture, we need 4 VMs, correct?
Yeah, right now, yes, we need 4 machines for the architecture that we are able to see on our screen.
Okay. Also the secondary will be there. Then I think 5 machines will be there, correct?
That is an ideal scenario. Yes. Ideally, you need.
Okay.
Shubham, I just want to confirm one thing.
Sure.
Like for 1 GB data, if there are 3 blocks, so all these slaves are having these 3 blocks, but working only on the 1 block, is it? And 2 blocks as a replication of as a replicated data. Is it?
No. So, again, assuming your block size is 64 MB, right? Where is my calculator? Block size of 64 MB 1024 divided by 64, it was 16, I guess. Yes. So data will be stored in form of 16 blocks. So 16 blocks will be there, 16 blocks will be here, 16 blocks will be here. Now, when distributed computing will come into picture and this master needs to leverage all of these three slaves, what it will say that, okay, first 5 blocks will be processed on this, next 5 blocks will be processed on this, and next 6 blocks will be processed on this. Now, since RF is 3 and all blocks are available on all the slaves, no data need to be transferred. It's just that first 5 will be processed here, next 5 here, and next 6 here.
Yeah. So it means that for the first slave, if first 5 blocks are getting processed, other 2 blocks are there.
Other 11 blocks. Other 11 blocks will be just sitting idle. Yeah. Those.
Okay. Right.
That particular data set will not get processed. It will be just in case of, you can say, disaster, when this slaves goes down, it will be then again create another task for this to process next 5 slaves.
Got it.
Yep. This is important actually. So I'm going to take more questions on this. If you have understood this so much that you can explain it to someone else, then you are good. Because believe me, right now in today's world, if you go for a data engineering or a data science interview and they are going to ask you a Hadoop question, one question from this architecture will come for sure in the interview. There is no brainer thinking related to that.
And one more question, sorry. Why we divided 1024 by 64? 64 is
64 is the default block size.
Okay.
Yeah. I mean, we can set that block size in YAML config file to 128 also, but yeah, by default it's 64. So right now we're taking 64 into consideration.
Shubham, I have one question.
Go ahead.
Like in these slaves, so what will be the networking? How networking will be established? Like it will be private IPs?
Right now you can think of it as LAN. They are on LAN, local area network. But yeah, they can be on private IPs also. There is no issue with that. In cloud computing today's world, normally these nodes have private IP, dedicated IP basically.
Okay.
Yeah.
So these slaves are basically 3 different virtual machines.
Yes.
So they are being set up like for all the 3 slaves, we have to do some kind of installation, common installation, client type of installation, right? Binaries.
Yes. That's why I'm saying, if you remember, right, initially I mentioned that we won't be doing anything in terms of any hands-on demo or anything related to Hadoop, because nobody does that now. 90% of the tasks that have been told as part of Hadoop teaching course are related to Hadoop administrator work.
Okay.
And now Hadoop admin work is very less now, because everyone is going towards managed resources, like managed clusters. Managed cluster in the sense you just do one click and set up the cluster size. Let's say you need 4 VM or 5 VM, and then in the backend, the cloud will install and make it up and running for make those VMs running for you. You don't
So
have
all the files are already there in those VMs.
Yes. By default, think of it as a VM backup file that is getting deployed to each of the machine and giving it to you right away out of the box with the connection available.
Okay. Maybe they are clones of some
Yes,
related to
they
some
are
specific templates.
Correct. They are literally. If you have worked with Azure, it's called ARM template, Azure Resource Manager template. So you can just deploy that ARM template on X number of machine in a single click, and all of those X number of machines will have the same config, same everything same, and they will talk to each other also on the same VNet.
Got it. And networking will be established. I think we have to there in the Azure or in the AWS.
You can do that. Yes, you can manually also do that. If you do not want dedicated IP and you want to use a public IP, that will be less costly. You can do that. But in that case, you need to separately create a VNet, subnet, make them on the same subnet so that they are talking to each other, check their gateways, and you need to do all of that.
So that knowledge is required basically, right?
That knowledge will be required as well. Yes, networking as well. If
Okay.
you are creating it manually.
Okay, got it.
Yes. So right now in today's world, everything is coming out of the box. So we are not trying to basically do the reinventing the wheel. If we have one-click deployment solution, then why should I tell you that, okay, this is what people used to do, now forget it. Learn this and forget it, because you're not going to do this now because it's not required anymore. Okay, so this is the architecture. Now we know how does Hadoop work, what are the different components, and I would say Devi, are you there? Okay, I'll go with then Shriyang. Are you there? Shriyang? Okay, he's also not there. Shrikant?
Yeah, Shubham, I'm here.
Okay, can you tell me the different, you can say, components or part of the Hadoop architecture?
Come again. Your
If you
voice
tell me
broke.
different components of the Hadoop architecture.
You mean the slave?
Yeah, I mean the master node, but it is called as name node, job tracker, resource manager,
Yeah.
like this.
So it consists of master and slave nodes, but master is also called as name node,
Perfect.
resource manager, and also in the background we have the secondary.
Master is called name node, but has resource manager and job tracker.
Okay.
Correct?
Okay.
Just to be on the same page, yes.
Okay. And it also has a backup that works like a backup
Mhm.
called what is a secondary
Name
name
node. Perfect. And it will also have job tracker and resource manager.
Yes. So
Correct.
secondary name node basically takes up when the master becomes,
Then,
when it stops
yeah.
working.
Yeah, it stops working. Correct.
So coming to slave node, we have data node, node manager, and also it also has a. I'm sorry with the abbreviations here.
Task tracker.
Task tracker.
Correct.
So in each slave node sends out a heartbeat to the master saying that
Perfect.
it is alive and it's working. In case
Correct.
it doesn't, then it restarts. It restarts the slave again.
Correct.
So coming to each slave node, it has a data node and node manager, which runs all the functions of the slave inside. And
A data node is what it is called as. Just the way master is called as name node, slave is called as data node.
Data node. Node
It has a
manager.
node manager is what, yeah.
Node manager is what runs the functions of the slave.
Correct.
And communicates with master, right?
Perfect.
And task
tracker.
Task tracker is what monitors the
all the activities that are going on.
Activities from the
Yes.
master and communicates it back with the
Job tracker.
Job tracker.
Yes. And sends the result.
Yeah.
Understood. Perfect. Thank you, Shrikant.
Thank you.
I hope everyone is clear what Shrikant has said, and we are so far so good with it. No issues there. If one slave goes down, replication factor is by default set to 3. So we're going to use a replica on the other slave. And that's how we can leverage distributed computing. And even if one goes down, we can still have the result retrieved from the other one. And by default block size is 64 MB. These are the some key things related to Hadoop. Now, what thing? Now
sorry to interrupt. I have only
Sure.
one question. Anywhere here, these are locally connected, right? But anywhere internet is not used, right?
No, right now in today's world, while they are on cloud computing, internet, they're available on internet. You can assign a dedicated public IP or a private IP, doesn't matter. And then you can make them talk to each other. That's what actually Rupesh was discussing.
Okay.
You can do it. Yeah, you can do that.
Okay, but slaves and master, when they're communicating, master will basically will be in the cloud, right? Slave will be a server in a organization.
No. Even slaves can be, so even master can be a VM and the slave can be a VM. Think of as master will be a VM which will have high capacity of RAM and low capacity of storage. Whereas slave will be the VMs which will have high capacity of storage and low capacity of RAM
Okay.
as compared to master. Okay.
Okay. So
Awesome.
these are all protected by VPN.
Yeah, you can keep them on VPN also.
Okay.
That's not a problem. Yeah, that whole networking concept comes here. Nothing you can be losing out. If you want to keep them behind you can say a load balancer, that is also fine. Behind a firewall, that is also fine. But people don't do that.
Okay.
Generally, people keep it over a VPN at max because VPN provides you that security and will not give any intruder any kind of access. Correct?
Okay.
Your network will become secure in itself, and you don't have further additional layer of the data security.
Okay. And also, slave can be accessed by multiple users. Right? A slave system can be.
No. So in Hadoop architecture, you never access the slave directly. You always talk to masters. Then it's master's job to interact with slave.
Okay. But
you can say that slave will be interacted only by Hadoop administrator in case, let's say, if it goes down or it needs a upgradation or something like that. Otherwise, slave will never be interacted with by a Hadoop developer. Hadoop developer has nothing to do with these slaves.
Master can be accessed by multiple users at different countries, right? Using replication servers and.
Correct. Think of it as if one company or one organization has one Hadoop cluster, right? Then whole company can access the master for any kind of task.
But when it has to be accessed by other user in some other place, then replication server will come up here. Right? So
I didn't get your point. Come again.
This master can be accessed by like people at different locations. Can it be possible?
Yes. X number of people can access it together also. So that's why this job tracker is there, right? If you, me, Rupesh, and let's say Jay Surya gives 4 different tasks to master at the same time, then this is this job tracker's job to manage all of those 4 tasks, assign all of those 4 tasks different number of resources as per the capacity available, talk to different task tracker at the same time, and give us all 4 the result in the best time possible. That's why these job tracker and task tracker are there.
Thank you.
Yep. Anyone else has any question? I'm going to take it as a note and proceed. I will clear it up. Okay, now so we have understood HDFS. This is what we were calling as here the resource manager, right? There is this guy. This resource manager is Jan. But I am not able to find here. Where is it? Where is it written? So you can just read like the resource manager work is done by generally here. Yeah. And comment it. We are going to discuss right now. So yes, the name of the resource manager is Jan. Earlier it was, I'm forgetting the previous name. So that was also there. But yeah, currently we are using Jan, I guess V2. Jan version 2 is getting used. Jan stands for yet another resource negotiator. What it does is it manages the resource. It basically works as a resource manager. So if you will see here, Yarn, job scheduling and resource manager, the job tracker and resource manager task, JT and RM thing that was there in the diagram, right? This diagram. I created a JT and this resource manager. That is nothing but Yarn. Yarn V2 is the latest. That's working in the world. Now we're gonna talk about something called as rack awareness. This diagram is not good somehow, but yes, I'm gonna tell you what is rack awareness and why it is important. Forget this. We're gonna talk about this only. Hadoop distributed file system and how does the rack awareness work. So now think of it as that you have VM1, VM2, VM3, and similarly this one is, let's say, 4, 5, and this is 6. Okay, I need another volunteer. Let's go with Jesuya this time. Jesuya, are you there? Jesuya? Okay, he's not available. How about Mayank? Mayank, are you there? Okay, when Mayank is not there. How about Shrikant? Are you there?
Yeah, sure.
Okay, Shrikant, let's talk about this rack awareness. Okay, so you remember, right? We had 3 slaves.
Mhm.
Let's suppose the 3 slaves were here in a single rack, VM1, VM2, VM3. First, can you just tell me that if you know what is a rack?
No.
Good. So think of it as a rack is a similar kind of, you can think of it as a rack of, you can say shoe rack you have, right?
Yeah.
A similar looking rack, but in that you can say different CPUs will be there.
Oh, okay.
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 So,
I
yeah,
got
think of it as CPU1, CPU2, CPU3, your
Okay.
physical, literal big CPU kind of thing. Okay.
Yeah.
And they will be very closely knitted and connected with each other because they are available on a single rack. So their transfer speed and transfer latency will be minimum. You can say that their interaction speed will be 1 Gbps.
Oh,
Like 1 Gbps, you can transfer 1 GB data within a second between these VMs because they are on a single rack.
Okay.
Okay. And now think of it as if you are in a different rack, then your transfer speed or latency will increase. Correct? Because you are on a different rack.
okay.
This can be one subnet, one single network, and now this can be another single network, and now you have to transfer from network 1 to network 2. Let's say VNet1 to VNet2. Let's suppose that. Okay. So if you need to send data across the rack, then that will be slower. But if you have to send data within the rack, between across the VMs, that will be faster. Make sense? And we know the reason why also.
Okay.
So far with me?
Yeah, sure.
Okay. Now let's say our Hadoop architecture that we discussed, 3 slaves, those 3 are all on the same rack.
Okay.
Okay. Now we were talking about if VM1 goes down, VM2 will be having the replicated data and it will work.
Okay.
Correct. And if VM2 goes down, then VM3 will also have the data and it will take care of the rest of the things. Correct.
Okay.
But what now I'm saying is that what if this rack network connectivity goes down?
Could be, yes.
Correct. Then what's going to happen? Are all, all of our slaves are down now.
Okay.
Now what we would do? Shrikant, you want to say something?
The master.
Oh, sorry. Rupesh was there, I guess.
Basically, we should have some backup of our whole cluster.
No. So now Shrikant is very smart. So Shrikant, tell me that Shubham, why can't we have VM1, VM2, and VM5?
Communicate with each other. No?
Yes, and create a cluster of these 3 VMs instead of VM1 and VM2 and VM3. So just in case if this rack goes down, this rack is available, and I can then use VM5.
But 4, 5, 6, are they like backup servers or all?
No, these are also
considered
available.
as a slave?
These are separate entity. Think of it as in a separate entity on a different server, a different rack.
Okay.
Okay. But right now what we are doing is we are clubbing not VM, VM1, VM2, VM3. We are clubbing now VM1, VM2, and VM5.
Okay.
So now even if our rack goes down, we still have access to one data node and we can still perform our task.
Okay. But
Make
will it not be slower?
Will it not be slower? You can say yes, a bit.
Mhm.
But our network is not down. At least it's up and running. Because if we will have all these 3 VM in a single rack and this rack goes down, then our network is down. We have only master, we have no slaves. Then who will do that task? At least in this case, we will have a VM to complete or accomplish our task and give us some result. Even if with some additional latency, that's fine. But at least our network is up and running, right?
Okay.
Make sense?
Yeah.
Yes, Akshay, you were saying something?
Yeah, please explain this once. Is that the backup of all VM1, VM2, and VM3 what we have in 4, 5, and 6 respectively? Do you mean that?
No. Those are not the backups. Think of it as these are 2 racks which have 6 VM, and now you have to spin up a cluster of the diagram that we discussed, right? Three slaves. So these are the 3 slaves on the same rack. First case I'm discussing. But if they are on the same rack, then the issue is, but if the rack goes down, then your no slaves will be available. So now Shrikant is smart. Shrikant says that I take 2 VMs from here and 1 VM from here. So even if my rack goes down, this particular VM would be available and I can still do the work. Even with some additional latency I have to do, but still I won't be blocked.
Okay, that means we are not like adjusting all the slaves on the single rack.
Yes, this is what we call as concept of rack awareness. That while you are creating a cluster, all of your slave machine should never be on the same rack. Remember, I'm not sure how many of you have worked on cloud, but there is a concept in cloud that we call as geographical redundancy. So what you do is you do not have all of your servers and your backup server in the same location. You have them in a different location. Because if your network of one location goes down, at least a different location network would be still available. That's why you don't have even if, let's say, I talk about a company who is in US, who is based out of US, who has users in US, they still might have a backup of their, you can say, database or a database server in a different geolocation. That is, let's say, Canada or maybe United Kingdom.
A replication server kind of like a replication server. That is what you're saying, right? That server, whatever the data entries or whatever the data that all are present is also replicated into another server just in case this goes down.
Yes.
That will take up.
Yes, backup thing. When I'm talking about it in terms of cloud, it is a backup. When I'm talking about here, it's not just about the backup. It's about creating the cluster itself.
Yeah.
Cluster of Hadoop cluster that we're talking about. So that cluster of machines should never be on the same rack, because even if the rack goes down, another rack should be still available. Right now, I'm not sure how. Have you heard the term high availability, HA?
No.
So I think whomsoever is coming from database world, they must have heard of this term of HA. So this rack awareness is required to ensure HA, high availability. High availability means no matter what happens, my system is available. So right now we are taking into consideration that even if this rack goes down, my system is still available because I have data on VM5. So this is why you can say to ensure HA or high availability, rack awareness is important.
Shubham sir, one question.
Yeah, tell me.
Yeah. So can we say that these racks 4, 5, and 6, they are like load balancing for these 1, 2, and 3?
No. So let's say this is rack 1, just to be on the same page.
Yeah.
This is a rack 1, and this is a rack 2. It has nothing to do with each other.
Okay.
These 2 racks are having 6 VMs. Now you need to create a cluster. So you have to choose like which all 3 VMs I need to take. So now, in order to make a cautious decision and ensure high availability, you are choosing 2 VMs from here, 1 VM from here, or you can do the vice versa, 2 VM from here, 1 VM from here. But the point here is never choose all the VM from the same rack, because if the rack goes down, then your whole system is down.
Right.
while designing the master slave system, we need
Yes.
to choose the VMs from different racks.
Yes.
But these two set of racks are being managed by the same master.
Yes, I mean it's not entirely true. So let's say I create another. There is a one Hadoop cluster which has VM1, VM2, VM5, and a master and a separate master. Let's say on some another rack. Okay. And at the same time, on that rack there is another master that is residing there, which is using VM4, VM6, and VM3 for another Hadoop cluster. So this is, let's say, Hadoop cluster 1, which has VM1, 2, and 5, and Hadoop cluster 2 can have 4, 6, and 3, and they will have different masters. They can have different masters. That's totally fine.
So it means that while designing the high availability, Hadoop
High
cluster,
availability Hadoop cluster, yes.
Hadoop cluster, these two masters, will they talk to each other?
No.
Like
I'm telling you that these racks have nothing to do with the Hadoop cluster choice itself. You can choose any VM for any cluster, and these two racks can provide VMs to X number of Hadoop clusters, irrespective of those clusters being independent to each other. They are not talking to each other. They are not doing anything. They are independent Hadoop clusters, Hadoop environment. Because in cloud, that's what happens.
But if they have different masters, how their different resource manager will understand ki this VM1 is in the rack 1 and VM5 in the rack 2, and they need to communicate in case of
I have never said that R1 and R2 is not connected.
Okay.
If you remember, initially I told you that within the R1, if you have to transfer data from VM1 to VM2, VM2 to VM3, it will be much faster than as compared to transferring data from across the rack. That is VM1 to VM4. There is a latency. I mean, if you're transferring data from VM1 to VM2 within a minute, it will take 2 minutes to transfer from VM1 to VM4, because this is two different racks, but they are also connected with each other.
But the job allocation is being done by master node. Master
Yes.
node will decide ki this will go to VM1 and this job is being done by VM5.
Correct.
So do they communicate to each other with each other?
Yes.
Master
Yes, I mean,
1, master 2.
No. So right now I'm taking two independent Hadoop cluster running at the same time, two different organizations. So they don't have to talk to each other, right? Hadoop cluster 1 will have VM1, VM2, and VM5. Hadoop cluster 2 will have VM4, VM6, and VM3. Now two different organization cluster, why they have to talk to each other?
Okay, it means
Also,
for
just a minute, this rack awareness, right? Is it same in this traditional distributed file system? Like the same characteristics works here as well?
Yes. This hasn't changed. This concept of rack awareness hasn't changed. So this is there from the times of VMware, the first virtualization concept when it came into 1980s or 90s. Rack awareness is still same. Within the rack, data transfer is always faster as compared to across the rack. And then same thing goes for within a data center, data transfer is always faster as compared to across the data center in the same region. And then the same concept applies to within the same region, data transfer is faster as compared to across the region. So yeah, standard concept, no change. Traditional versus Hadoop, same. Remember, we were always talking about, when we are talking about Hadoop, we are talking about commodity hardware. Commodity hardware is what is already exists, is what's already there in the system, is what's already available for use in our day-to-day life. And this is what is already available, was already available. And that's what we are using for the fullest in terms of Hadoop system also. So, okay, people are asking the question, Sayal is saying, means each rack have separate master? No, does not. It's not necessary. Rack and master has nothing to do with each other. You can have, let's say, 3 different master managing 3 different, on the same rack, these 3 different VMs. So let's say I have Hadoop cluster 1. Let me make it HC1. HC1, 2, 3. This Hadoop cluster 1 has VM1 and VM4. Then this one has VM2 and VM5. This one has VM3 and then VM6. 3 Hadoop cluster running in parallel. This rack has nothing to do with the Hadoop cluster itself. Now, right now, I'm assuming the architecture of Hadoop cluster is having only 2 VMs. One here and one here. So yeah, master has nothing to do with the rack itself. Then Rupesh is saying these rack are like different data centers. Not necessarily. These rack can be in the same data center, right? Like right sitting next to each other, the way they are sitting here in this diagram.
Right. One thing I like to discuss.
Yes.
Like in in Oracle database also there is a functionality called rack real application cluster,
Yes.
where
It is
the
similar to that.
yes, and where the nodes are basically from the different data centers,
Yes.
and so that if any node goes down or any earthquake happens, so in that case the data will be always available.
Correct.
So so whole thing is there to do the data availability.
Correct.
So
That's
system
it.
will not be down anywhere.
Yes. But the only thing is, I would like to add what you are telling me, Rupesh, is that is HA with DRM. If you will see, right, you will
Right.
be looking
Data
with
register.
high availability with disaster recovery management. That's why you have two different data centers. Right now, I'm not talking about DRM, disaster recovery. So these rack can be sitting right next across to each other. If we are talking about
Right.
disaster recovery, then what you are saying makes sense. Then we go across data center, across location. Then these rack will never be sitting right next to each other. These will be either in two different locations or two different data centers. Right now, I'm not talking about disaster recovery. Right now, I'm just talking about high availability.
Right. And one more thing you also said, right, that now these data centers are basically replaced by regions, and the same region have the high speed and same speed, basically more
Yes,
speed as compared to the other regions.
correct.
So that is, yeah, okay.
That is what we call as local redundancy and then geo redundancy. Local redundancy is when they are sitting next to each other. Geo redundancy is what you are talking about, like two different data center or two different locations.
Right, yeah, got it.
Yes. So now I want someone else besides Rupesh who can
One more thing, sir. Subham,
explain.
I would like to
Yes.
add here. Just
Yeah.
one more thing, then I can proceed.
Sure.
Similarly, in AWS, when we take the cloud services, we need to
Yes.
select the Asia Pacific or some region.
That is same thing.
And
But we are
and in that case, if that fails, can we that will shift to some other region
yes.
because they have already their replica in other data centers or other regional centers.
Correct. That's what we call as geo redundant. That's true. So KK is also on par with me. Now I need someone besides Rupesh and KK who can tell me what's going on here. Just one more guy and I'm good with it. Meanwhile, if anyone has any question with respect to this, because this is essential part of Hadoop architecture. And while I'm saying you can have an interview question, if you do not believe me, I'll show you. Give me a sec. Why I'm laying stress on this. Mouse. I'm pressing escape. Okay. Explain the big data and list of its characteristics. Already I have done. Explain Hadoop and core components. Already did this. MapReduce, we're gonna come to it. But yeah, HDFS and YARN is done. Storage unit, HDFS, we have discussed in detail. Name node, replication, data node, metadata. What else? Rack 1, rack 2. See, this rack concept is still there. I'm pretty sure there should be an independent question with respect to rack. Yeah. So why are blocks in HDF is huge? What is default replication factor? What is it? 3 only, right? How can you skip the bad records in Hadoop? Metadata. Which command is used? These are command related. Okay. So if you see, right, what we have discussed, everything is there. Job tracker, task tracker, heartbeat, block. What is meant by rack? Secondary name node. I mean, whatsoever we are discussing, if you will go right and search top interview question, that would be there. That's why I'm laying stress on, like, if you are not getting it, ask me again, not a problem, because that's all there to Hadoop. There's nothing much more, because as soon as this concept is done, we're going to go into map reduce. Then once map reduce is done, then there are only a couple of more things in terms of workflow that we're going to discuss, and then Hadoop is done. That's all there to Hadoop in terms of interview questions and everything. So yeah, if you have any questions, feel free, ask me. Oh,
Shubham,
that
will you show the setup of this Hadoop on the VMs or on the clouds?
No. Actually, if you want that, it's as simple as, which cloud do you want? AWS?
AWS, yeah, no issue.
I think this guy is fine, yes. As simple as that. I'm sorry, let me even show you how old is that video. So it has 1 year ago, 5.5K views. What I'm trying to actually show you that it does not have hits. I mean, it's a good video, 50 minutes, step-by-step tutorial. Still people are not watching it because people are not using it. I'm not sure how many of you, okay, I think KK is from AWS World, and I think you, Rupesh, are also from AWS World. Are you aware of EMR?
No.
So EMR is Elastic MapReduce. Managed service. You don't have to set up anything at all. Just spin up a service of EMR, write your code into it, and it will do the task on your big data. Nothing needs to be set up. Okay. This is just like people are doing now. This is just for practice in case if any X number of organization is managing an on-premise cluster. Otherwise, yeah, everyone is going towards managed because it's pay as you go. You don't have to maintain. You don't need an administrator. One-click deployment solution is there. As and when you want, it's there. So everyone is going towards managed service. Amazon EMR is the AWS counterpart of this. In Azure, if you will go, Azure has HD Insights. I mean, X number of things that you can do with both of these on any of these cloud. Even IBM has big infosphere insights. So yeah.
So basically, EMR is given by AWS to deploy these services easily.
No, EMR is simply basically you just need to write the program, and automatically it will run on a cluster, whatsoever cluster size you choose, whatsoever RAM size or whatsoever the config you choose on it. You don't need to create anything at all. You just need to write the code and select the dataset. It will push it to the cluster, the code, get you the result. You don't have to do anything at all. Just write the MapReduce code. On the other hand, Azure HD Insight is basically a one-click deployment solution to create the whole environment, like this master-slave architecture for you within the Azure. So I've sent that YouTube link, Rupesh, for you. You can just refer to that, and that's that to it.
Okay, Shubham, yeah.
So I think no one has any question, and I think we are good till rack awareness. Good. Let's just cover this Hadoop block size. There's nothing. Latest version is Hadoop 3 that's going on. blah, blah, blah. In version 1, the input splits into 64 MB. In version 2 and 3, input file gets 128 MB. Huge block size leads to lesser number of blocks, which we discussed yesterday, right? Which makes the IO operation faster and easy. So anyone has any question with respect to block size? But I mean, it's 2. So feel free to ask me question regarding the block size if you have any.
Installing Hadoop cluster basically means installing these master and slave architecture
Yes,
on the cloud.
Yes, but if you want to try it on a local system, then just have a virtual mode for a VMware and try to use Hadoop in a standalone mode. Not instead of a cluster mode, use it in a standalone mode. The things that you won't be able to do or check in the standalone mode is it will have only one node, right? Which will be acting as a master node, and then the data node, there will be only 2 nodes, you can say that. So you cannot test replication, you cannot test backup of the nodes, you cannot test if one node goes down, then what happens, you cannot test if the master goes down, then how does the secondary node comes up. You cannot test all of these functionality, but rest, all of the Hadoop commands, you'll be able to test. I can share one file with you if you want. What I can do is instead, I have this. I'll share this text file with you. So this is a Hadoop file for, let's say, starting the services, checking the Java processes, list of all content, list of all users, copy from local to the destination, like from your local server to the VM. Once if you have VM or online AWS, then let's say copy from local to HDFS, HDFS to local, cat command, reading the content of a file, moving the file, copy the file. I'll share this. This is a handy command list I have, which I use initial, a learner should have. Yeah, I'll share this file with you. This will do. But yeah, any question related to block size? So currently, if you see, right, 64 MB was the block size in version 1, but in 2 and 3 it is set up by default to 128. And the reason being, you can say, greater the block size, the lesser number of the IO operation you need to do, and it will be faster and easy. But at the same time, we are not going towards, let's say, then someone can ask me, then why we are not creating a block size of 1 GB? Because then remember, right, if you have a file of 100 MB, then again, you'll be assigning 1 GB of 1 GB block to that file, and then your 900 MB will get wasted. So your block size cannot be too big, but at the same time, it cannot be too small so that your IO operation gets increased and slow. So this is a sweet spot that people have cracked. 128 MB is a fair enough size for HDFS because you'll be using Hadoop only when you have a big data, correct? So if you have big data, 128 MB works because 1 GB will be there, then you can say converted into 8 partitions. 8 blocks will be there for a 1 GB file, and which is a fairly good amount if you want to do distributed processing. Correct?
So purpose of creating such block size is basically just to make the R operation very fast, or breaking data into a smaller chunk so that it will process in a very fast way.
Correct. There are many reasons. So one reason is saving time and easiness. And another reason is, you can say, maintenance. The lesser number of the blocks will be the lesser number of metadata you need to manage. Correct. Another reason for having a bigger block size, or you can say the block size to be limited to 128 MB is because it is easy to replicate. If you want to set a replication factor of 3, right, by default, you keep it default to 3. Then replicating a 128 MB block is going to be much more faster than as compared to replicating a 1 GB file. So replication become easy, backup become easy, accessibility become easy. So yeah, there are X number of reasons, just not the fast thing. But yeah, another thing you can say that if you want to do distributed computing, you need blocks. If you will have, let's say, 1 GB block size and you need to process 1 GB file, then you cannot do it in parallel. Correct? Because 1 GB file, 1 GB block size, it will be executed only on one single node. But if you will have, let's say, 128 MB block size and you have 1 GB file, then 8 blocks will be created. if you have 8 VMs, you can send those blocks to 8 different VMs together and have them processed in parallel, and then your time will be reduced by 180. So there are many reasons to have the block size as 128 MB and not bigger, or not too big and not too small.
And
So-
Shubham, the block is basically basically representing the same thing, which is the actual data
Yes,
represent in terms of properties there.
yes, it is actual file which is getting divided into 8 blocks. 1 GB file divided into 8 blocks is 128 MB, 8 blocks.